Perhaps it's interesting to show how I do my experiments before I publish a certain circuit on YouTube. Like you know, when you have followed my channel, I always use this kind of setup: brass nails on a piece of well varnished soft wood. And during this week I was busy with Class A amplifiers. I have published, say, a first idea of such a Class A amplifier made with 2 Darlingtons. But I wanted to go further and made now a circuit that has somewhat more audio output level. And it's not big, it's only 500 milliwatts, and that's what I hear during, say, all the time that I made audio amplifiers in the past. And here is the sketch of the circuit. I always make a sketch at first, try different transistors out, and well, of course I did it also here. The BD139 that I've used in the, say, Darlington burned out. This transistor burned out the BD743C, and it is a high voltage transistor. So that was very, very strange. But in such a case, such a transistor is dumped. This one is not dumped, of course. It was also used in the 2 earlier schematics. Anyway. Well, the idea in this circuit is that the loudspeaker is in the collector lead here, and here we have a kind of Darlington. As far as I know, this is also known as a Schiesley circuit. I hope I explain it right. And that was more or less the first part of the experiment. So this part was the first part of the experiment. And the even earlier part was only the 2 and 305, and then here at the base, with the help of a 470K potentiometer, you can set the bias and then send into that first transistor via a capacitor an audio signal. And then you hear when the transistor is healthy. That's of course very important. These 2 transistors burned out immediately, and I don't know why, but anyway, no problem. When you send, that's by the way the reason that I've used, say, the workhorse, the 2 and 305. It's difficult to damage a good 2 and 305, but anyway, say, this voltage divider here was in the very first experiment connected here, and then I sent in to the base via a 470 nanofarad cap the audio signal. You can hear a little bit the sound because it amplifies a little bit. Say it amplifies 70 times, but when you have an input voltage in the order of 200 millivolts or so, that cannot drive out properly in a heavy way the N transistor. So I use a second transistor here, the BD140. I have by purpose used here a BD140 and not a Darlington with a BD139, because I wanted to experiment it out. And when you do these kinds of experiments, always a good idea to take the resistors here in the first part of that experiment a little bit high. And then I'm talking about circuits working in the order of 6 volt up to 18 volts. 1K is often, say, a good value to realize that the current here will be not too high. And when we look at the N transistor, I've used by purpose here 22 ohms. I only apply Ohm's law, and that means that the maximum current in the 12 volt situation, when the transistor is driven into saturation, and that's of course not the case when you make an audio amplifier, only with a switch the transistor is driven into saturation. So anyway, it's a kind of, say, safe idea to limit the current. And I found, for instance, during all these experiments, that when I bridged that resistor, it had absolutely no effect on the sound. So this was the second experiment. Here, still not enough audio out. I found that here, this resistor, at first I used 1K. When I made it smaller, that are also, say, important things to do. Change values of resistors, listen to the sound, look at the oscilloscope, how properly the sound is amplified. Without an oscilloscope you are more or less blind, always blind, thus you need that. Anyway, when I made this value of this resistor smaller, I got far more audio out, but when it was too small I had a lot of distortion, so found finally that 330 ohm was okay. In fact, we do here exactly the same. We use here a 470k potentiometer to bias that BD140, but because I've used here a BD140, that's a PNP transistor, that means that it starts to give an output current in the emitter collector lead when the base is made negative. And in this case, the collector emitter current will start to flow when the base is positive. And it is made positive, say, by making this transistor on its base negative. So when this transistor gets negative on its base, it starts to conduct. That means that this transistor, the NPN type, gets a current here and starts to work, drives the loudspeaker. And this is because it's class A, there is a constant current flowing, and I have explained it in an earlier video. Anyway, this was made, this was the second stage, and still not enough amplification, so I added here a stage where the voltage could be amplified. And I made it in a more or less classical way, from the collector to the base 220k, in the collector lead 1k, and here in the emitter lead a 500 ohm resistor. When you make such a circuit with a NPN transistor, it's often good enough not to use here a 500 ohm resistor. Anyway, you can directly connect it to the, in that case with an NPN, directly to the minus, but now it must be connected to the positive lead, of course, because the, sorry, yes, it's the positive, this is a negative. With a PNP transistor here, this one, we have the collector on the negative and the emitter on the positive lead. And with an NPN that is reversed. Anyway, 220k here, and sometimes you do kind of inventions. I found, for instance, that when I connected parallel to the emitter resistor a capacitor, it had an enormous effect on the amplification, and that's logical because the same happens with an NPN transistor, and that's the reason why I've made here this part. Oh, also a capacitor. This is, say, the mirrored circuit. And I found with an electrolytic I had oscillations, but with 47 nanofarad it worked as a kind of loudness. So these are, say, the basic understandings of such a very, very simple electronic analog electronic circuit. Anyway, let's listen to the music. Important to tell, when I lifted up the voltage between 5 volt and 12 volt, nothing happened in terms of, say, audio output. And that has, say, in a certain way also to do with the type of circuit here, because it's a class A amplifier. There's a constant current flowing here, and that current is modulated by the audio sound. Let's listen. Hope I can find it. End of Summer. End of Summer by the 126ers. This is the loudspeaker box. Now you hear distortion because I lift up the audio level too high. And say, in these situations, it's always good to use at first in the collector lead such a loudspeaker, or even such a tiny loudspeaker, so to get an idea about the sound, and of course connect your oscilloscope to the loudspeaker and also to the input. In the input you can see how the say the music, all these sine waves are sent into the amplifier, and here you can study how good they are amplified. Is there distortion, etc., etc. Distortion often means clipping, say that sine waves get into square waves. Anyway, let's listen. Hope that it works. Scope. Some music. And I found, like I told, that, stop please, that with that 47 nanofarad cap here in the circuit here, I also had, say, a big lift up of the base level. That means that this circuit, I had not expected that, but anyway, also acts as a kind of loudness circuit, and that means that this circuit will properly work on say very low audio output levels in your living room. Perhaps I'm going to make a neat circuit, perhaps I'm going to do more experiment, but well, my idea was to tell something about doing experiments, what you can expect, especially very important. Say that you can always set the bias of a transistor here with a 470k potentiometer with two 1k resistors here. That regards to this transistor, also even to this transistor, though here I have used a more, say, primitive way of biasing a transistor. You can also find that more or less primitive way that properly works, by the way, in old 1960s electronics books, etc., etc. Well, that was more or less all to tell. Thanks for watching. Some music when everything wants to work. And I found that changing the supply voltage has not a big effect on the output level. So it works on 5 volts, but also on 8 volts and on 9 volts. And the transistors don't get very hot. That's also very, very important. Well, that was more or less all. Thanks. a very long video. I wanted to make it very short, but it did not succeed, because all these experiments, when you want to explain that in a somewhat understandable way, takes a lot of time. And this was published in an earlier video. I also used it, but found that this way of generating music to test such a simple amplifier works a little bit better.